Good morning, everyone. I'm going to get started. Welcome to this week 10. We are in October 26th on a Monday. Happy Monday. I hope you are doing well and you are surviving your courses and taking things the way they should be. I can imagine it could be a busy time. So we are going to kind of have a place where we come to see some codes today, a lab session. The last time we did something like this was when we discussed regression, and it coincided to be on a Friday. And so we had a series of lectures, and the last one on it was a lab session. This one is not like that. So we are not done with the topic of classification. There is a couple of topics left. And there is also a topic on cross-validation, which I am going to emphasize, and I look forward to having you next class, next Wednesday. But we have finished 4 different methods for doing classification after having introduced the topic. And those were logistic regression, k-nearest neighbor, and the last lecture we saw linear discriminate analysis and naive Bayes. And so of these 4, 2 of them will be the subject for today's lab session. And the lab session, like we have seen last time, would be for me to go, and this will be emphasizing R, an open up code, and we work through the code together. So for those of you who have had a different kind of workload and things like that, what we have been doing, and I know you can watch afterwards, what we have been doing was more of subject discussions and slides, but today would be a walkthrough codes. And we come back and do the usual type of discussions next time. I've got 2 pictures on today's slide, and I'm going to stop doing this, and we'll go to the code part in a moment. But the left one doesn't need any explanation. Surprise, surprise, we're still in October and it snowed last weekend. For those of you who are in Pullman or close by, that's not the news, you have seen it. But for those of you who are maybe far away and maybe on the west side where it didn't snow, please know that it snowed here. And so that's the picture. On the right is a connection to our assignment 5. I know some of you are on the way, and I saw some of you will be working on it the rest of this week. The last problem on it, one of the problems there, the last one, has to do with classification of articles in a newspaper, and so you know what you are going to be doing with it, or you have already started doing something, and it is going to be using naive Bayes as an algorithm. But it just gave me an idea for a warm-up question today. And the warm-up question is related to the picture you see on the right. I'm going to ask a volunteer today, and then I'm going to ask just somebody, write something, and you will say, I'm going to be typing a warm-up question today. I have always picked the name. Let me see if there is a volunteer. There were 1 or 2 days where I missed. I said I called upon a name, and that person was not listening to me, and so it was not typed. So let me see a volunteer. Just quickly, somebody say me. Just type me when you want. And the first day who says me will get the chance to write the newspaper question. Okay, Harry's going to say me first. Harry's going to write. And Harry, you probably would know there was a day where I called on you and you didn't hear me, and I was disappointed. So I'm happy that you're going to write now. So the question is very simple. What is the newspaper you read the most? It could be print or online. And so this picture is trying to show you how things were in the old days when people used to read them in print. Okay, it may not be the case now, and it might have been the case for a long time now. Go ahead and tell me the newspaper that you mostly read, online or print, it doesn't matter. That's the warm-up question for the day. Thanks, Harry, for writing it. You go ahead and participate. If we have time, I'll throw in another question today. But before I go further, let me just have another slide on this one to discuss a couple important dates that are upcoming. And then I'm going to go to Chris, to you to go just do a little bit of a walk in Blackboard for things that I have been very busy this morning posting, and I'll point out a few important things there. So just a few reminders. Assignment 5 is due a week from, or this weekend on Friday. Okay, that was one thing. The other thing is I want to have a kickoff meeting with each one of you, with each team this week. And I have told you last time, And I did pick 3 days. I did not do dual poll out or something like that, but I'm going to go back and show you where I would like you to sign up. I have tried to look at my own calendar and try to give as generous as time as possible, as many options as possible, and we must meet. And I need to meet with each team for a few minutes at least. And so I'll take you to the place where when Chris takes over and shows his screen, there will be a place where I will show you what options there are and what you would need to write up, okay? That's what will happen this week. That's another reminder. No, oh, okay, that was not exactly what I wanted, but that's okay. Okay, since you've taken me there, Chris, let's go to Blackboard then. Okay, so the place I wanted. Okay, so I got a little bit off guard here, Chris. It's my fault, I know. The place I wanted to sign up, I will come back to it. But let me since we are on Blackboard here now, let me go to content, and I'll come back and tell you the right places. Okay, so if you go to content, the first thing I want to do is, okay, this is where I got a little bit off track from with the way things were. So let me start here and point out that there is a couple of documents I posted. So the first thing I want to tell would apply only to 575 students, okay? 575 students, there is, in addition to project and assignments, you will do a survey paper. And so that call has come out, and there is a folder I created, the fourth one, that's called CptS 575 survey paper, okay? So there are 2 documents posted there. One is a call out. That means you're going to have to do, to tell me the topics that you would do. You can click there. The topics that you are going to choose, and this call came out today. Magnus has asked me, here's your answer. You were not late last time. So this came out today, and it will be due on Saturday. And it's going to be a very simple thing where you would tell me the topic you would choose for writing your survey paper. Your survey paper is going to, here's a little description, as you've got 2 major ways to think about this. One is to choose a topic that is related to your semester project, but looks at a certain particular thing, a little closer in the literature. Something that is around what you do, but you don't have the time to, too much to get into it in the project report itself, and you are more focused on other aspects, but there may be a topic that's on the periphery that you want to look into. That would be a good choice for a topic. The other is to do completely separate thing that is not related to your semester project at all, but you have a topic that you want to explore. And so these are the 2 options you have, and both of them are fine. Unlike the project report, which is team-based, the survey papers are going to be individual. So they would be written one by each member. And so if you are a team of 2 or a team of 3 and you have something that is related to your project, talk to each other so that you would know you are proposing complementary things rather than the same thing. If you are choosing something completely different from your project, it's nice if you talk, but you don't have to, because you are choosing something that is unrelated. So you have by now understood where we are, known what topics we're covering, what is left. You also know what project you're doing, so you would make a good choice in what project topic you would write for your survey paper. There is a list of topics. Now you can scroll back. A list of topics I have suggested, and this would be probably a good coverage. It's not comprehensive, it's not everything in the world, but it would be a good coverage of potential topics that might be of interest to you. So topics on deep learning in a particular area. Every time you see X here, you can substitute it with your own area, whichever way you come from or whichever thing you have interest in. Otherwise, the first thing, if I say just deep learning, that would be a huge topic on its own. You will not be writing any survey paper around that. Or generative adversarial networks or reinforcement learning, all of these things in area X, So you can go down the list. There are very many good topics. Towards the end, there is a couple things I want to tell you. For example, the 3rd last bullet, bias and fairness in algorithm decision making. This is a big topic these days in machine learning, and we don't cover it in this class, but this is related to, what do you do when your recommender system is reinforcing implicit bias people have. hiring decisions are making, or people are trying to match up college decisions and they try to rank, who should go to which college or which applicant should be coming on for an interview. We will, at the very end, I know some of you are looking forward, there are ethics issues we will discuss, but there is also things that is very much in the forefront of what's happening now, people are trying to figure out, including some novel new ways of algorithmic thinking in terms of to have to include in your framework in how the algorithms are designed to account for bias and fairness when decisions are made. These are actually useful also when decisions are made by humans. You can imagine how much things would have been better if this were, kind of written down. If somebody had actually a rubric, like just like when we grade your assignments, we say, if you do this, this, and this, you will get this grade. If somebody actually had written down something like that when they make decisions, things could be fairer. And so that type of thing is a good place to read on. And I have interest in those type of topics. Data science and privacy is a big topic that we don't have a whole lot of time in class to cover. This will be a good topic to explore, to write a survey paper on. So 475 students, you are not writing survey paper. This is one of the places where the distinction comes. The other place is the kind of projects you do, but this is the main difference in what they are. So that was the call out. It's due, you have time. You have time to think the rest of this week if you haven't thought about it. But if you go back to, again, stay there. I've got also a guideline, and the report itself is due December 7. I just made it a week earlier than the final report. When you write your survey paper, please read this one, and it is a guide, a good guide to see what you need to include. And I've got some suggestions. First, when I grade it, the first thing I would do is do automatic, software to run that this is not something that you really pulled out of something, right? So I have a way to check that. So make sure that you don't do that. I don't think you will do that, but sometimes it's a little tempting to have a chunk of thing copied from somewhere and put it in your report. Don't do that. And otherwise, I've got a little format issues, how much of a size is needed. And if you scroll back a little bit, Chris, when you do a good survey paper is not something that says, here is individual X, they did work Y. Here is another person and they did this other work. And here's a third person, they did this other. That's not a good survey. Of course, you will do that to some degree, but you have to synthesize it and look at it from your own perspective. So distilling that information and telling somebody else what this thing that you surveyed is what a good survey paper would look like. So that is synthesis. And try to come up with a way to systematically categorize whatever it is that you're reading. So something will emerge. You can classify them in some ways, or you can categorize them in some ways. There may be some kind of way in which you could come up with a good way to visually look at that, to have a nice diagram or something like that that would accompany it. So if you go through these bullet points, you would actually get a good deal of good tips on how to write a good survey paper on. This will probably be the only time I want to talk about it. So I apologize for 475 students, and I know you can forgive me. This is not something you will do, but this is what your classmates are doing. So all the time, whatever discussion we have, I try to make it relevant to both groups, but this is specific for 575 students. Okay, let me go, Chris, go back to content and then see what other thing I have posted. If you go to, so this was item number 1, 2, 3, 4, right? Under projects, there's one thing that has been added. The folder was there all the time, but it is now added. So you already know that you have the first item from last time I posted, the teams that are in this class now, as they are composed now, but I also added today a final report writing guideline, much like the survey paper guideline. Please click there and we will take a quick look. When I talked about projects, there was some rubrics. I told you, there are 4 or 5 things that I say your project should meet. This is a more detailed guideline, how to organize it by kind of having abstract, you've got references at the end, you have introduction, you've got problem definition and things like that. What I have done here is to tell you what could go in there. So this is a good guidance, a good way to organize it, but these are not necessarily section headings that would show up in your report. These are things that you could think around, right? And sometimes they would just naturally fall and you would be just fine using them as section headings, but sometimes you may come up, depending on the project you're doing, another way. I've also indicated how much weight I would put when we grade this. So you know, the abstract, if you forget it, if there's no abstract written, of course, you will not get any points, but here is a rough guidance and they would add up to 100. So you have read already what projects are supposed to do, and there was some rubric I gave you, but this one is a more detailed guidance on what sections to include, what should be included in each section, how much weight I would give, and you will see that I would give a lot of emphasis on your implementation, on your analysis, and the models and algorithms you discuss, rather than, you know, the other things. So they are carefully thought out, and so this is posted today. That is one thing I wanted to show on projects. I guess these two were the ones I posted and I wanted you to know. I have posted, if you go to content and lectures, go to lectures. Just like we do all the time, if we go to today's date, you will find the R code that we will be running. And so you can follow along with me when we get there. This, I called it classification lab session. And so there is an R code, but I would also be running R from my laptop, so you will be okay if you just follow me there. Let me go back and see if there is anything I forgot in my slide. I think that was it, if I didn't interrupt the dates that I was trying to show you. So I remember them by heart, so we could you could stop sharing and I can tell you. Thank you very much, Chris. I can tell you, maybe I can share just so you see it again. It's going to be a quick one. This is what I was. Okay, so we've talked about all of this project. The only thing I want to remind you, because it's here now, is there is a progress report on November 4th, and the final report itself is due the very last day we could have, and that's December 14th, and the guidance has been posted. For the survey paper, I have told you all of the things that are listed here, and I just want to remind you, there is a midterm, and then we'll do that in a week of November 9, and there is nothing like you will do online, it will be take home. We'll talk about that when the time comes. I think I just wanted to be sure that I covered all the points I have here, and I'm going to stop sharing this and go to the R session we have. And I'm going to ask you if you have any questions for me so far. I know you were busy writing, telling me the. It's not something you need to do now. It's not a question for me. Okay. Okay. Anybody else got any questions for me? All right. Let's go get started now with the session we have for today. And let me see if I can find it. Going to need some time here. Perfect. I think I need, okay. Can I get a thumbs up if you're seeing that my R studio, okay. Okay, just like last time, we're going to walk through this code, and I think I have made it large enough so you can see. What are we going to do? We're going to do two classification methods, logistic regression and linear discriminant analysis. And I'm going to be using a package that is available via the book that we have been following for the last few lectures, and the one that we'll be following for at least one or two more. And that book is called, Introduction to Statistical Learning with R, and they have a data set or a collection of data sets that goes by this name, by the same name. And so we're going to be using a data set from that book, from those authors. And you might remember, and you probably have done it yourself a few times, whenever there is a package, a library that you would install in R, you would say library and you write the name of the library. Much like that, there is another one called require. It does an equivalent job, but I just wanted to show you an example of it. And so this discussion today is going to begin by having to, let me see, by having to require that package, ISLR, so that we have it available. And we'll be looking at stock market, of all things, today. And stock market is a place where things are very volatile. Things go up and down all the time. And this is a real example from some years ago. And so we'll be working with that data set, which is found in this ISLR. And it is called S market. The S there stands for stock, okay? And so we'll look at what it has. So names will be, as you know, a word that you could use in R to find out about the data frame, in this particular case, you're working with, and it will tell you the variables that are associated with it. So this data frame has got something called year, and then something called lag 1, lag 2, lag 3, lag 4, lag 5, volume, today, direction. All these lags are things that are, you may remember even a function we called in R that tells you how many days back you are looking at. So the previous days, in a way, is what this means, these various lags, and the volume is how much was sold, and today is what the stock market looks like today. Direction is a Boolean variable here that will tell you whether things have gone up or down compared to how they were the day before. And so we've got these variable names in this data frame, and we're going to look at its dimension, and dim is a keyword, or a function name in R that you could use to apply on a data frame to find out how big that one is. So we've got 9, and if you count the names, the variables that were associated here, that would be true, and you will find out immediately that is the case. And this thing has got 1,250 rows. That's the rows and columns is what you get when you write dim. Let's find out a little bit more about this data set, and we can write summary. And when you write summary, you'll see what I have on the bottom screen here. I'm scrolling up here, and so you can find out what the values are, and you get a summary, right, about the 9 variables that you have, including the down and up values here, how many of them are really down and how many of them are really up. Okay, so that was summary. We can query just like we do. If I have a function in R that I want to know, I could use the question mark and find out about it. If we do this on S market, we get what is displayed on the left here. And this is an S&P stock market data. It has got a description, its format, much like the Boston or the housing or the car or the auto data set we saw last time. We've got some explanations on it. I don't need it very much now. And so I'm going to go and expand this on just a bit, or maybe I can reduce it a bit. So we got familiar with this data set for now, and we know that it is about stock market, and we're going to be do some predictions or some classifications, and in a moment with the 2 methods we have learned. Before we get there, let's try to plot this. And we're going to plot this using the pairs command. And this is going to take a while because it's a fairly big thing. And what we are plotting is this data frame S market, and we are going to use color. And the color that we are going to use now is going to be the direction, the one that goes up and down that you saw when we saw, and in fact, it's right there. You can see it on the console. 602 of them were down compared to the previous day, and 648 of these entries were up, right? 608, so this is more like half-half. So we used color, which is a parameter that you can specify to indicate which direction it was going. And in this case, there were only 2, and it's a good idea to do something like that. So it's kind of a bit crowded here, and it's difficult to see, and there doesn't seem to be much of a correlation. So by now you are experts in doing scatter plots of this kind. Pairs was That's the way we did it. And what we did here, other than doing it the usual way, is assigning colors to these two. And so one of the directions got a black, the other direction got a red. And it seems like all mixed up, except for probably where what it says today. And that's a clear separation between how things were, which is exactly what this data, the up and down would tell you. Otherwise, any other thing, the lag 1, lag 2, the year, they don't seem to help out in making this thing clearly separate between one or another. So we know that much about the data, and it is not probably all that surprising. Okay, so we're ready now to do two of the methods we have learned, and we'll begin with logistic regression first. Okay. The way you would fit a logistic regression model on a data set is to call this function called GLM. LM stands for linear models, and the G stands for generalized, and this is a function called. And you would do, much like you would have done in a linear model, the response you want to predict, that will be, or to model, the response will be the first thing that you would write. In this case, what we wanted to see as a response is direction. And then we are going to list out all the variables that we would include in our model. In this case, we decided to have everything, lag 1, lag 2, lag 3, all the way to lag 5, volume, and we say the data is this S market. And the thing that makes it GLM is a function call that gives you access to logistic regression, a logistic regression model. But the thing that actually makes it logistic regression is this family binomial. If you choose some other thing there, you will still have a generalized linear model, but it will not be logistic regression. So there we go. Line 11 has given us now a linear model, a logistic regression model for this data set. And let's try to find out what it has in it. And so I could write summary just like we did for the data frame itself. And so we do that. When we do that, we get some information, and we get things like, the first thing we'll find out is the call. And then we get some information about deviance, residuals, and the mean, the first quadrant and the third quadrant, and marks, and so on. What is interesting here for you to see, and probably one thing that your eye should immediately go to, is this coefficients we got. So logistic regression, it's been a couple lectures ago, so if you have forgotten it, but you've got these parameters, right? These parameters are the coefficients. And so you could see for these predictors what coefficients you have. And the last column here shows you the p-values, and that's where you would know whether something is significant or not. And we would call it significant when the p-value is small, as you all know. And by small, we mean really, really small, like 5. And none of this thing comes anywhere close to 5%. In fact, some of them are really high. So revelation number 1, the stock market is hard to predict, and all of these predictors are not helping us. It's not really that surprising, but there you have it. So you'll see that none of these things are really significant, but some of them are slightly better than others. So that is what our summary showed us. And there is a few other things that you could see. There's a little bit more detail you would get here. For example, there is something called Fisher scoring iterations and things like that. You don't have to worry too much about it. That's probably one indicator for why some of this thing has taken a slightly longer time than you'd have seen when you do linear regression, linear fit. Has to do with what we discussed on how these parameters were computed. I told you that this was computed using maximum likelihood estimation. Those are happening there, and then there is a certain number of iterations that will happen before it gets settled to finding a solution to that optimization problem. Those things are expensive. If you were to implement these things yourself, which you'll never, rarely do, whatever tool you're using, they are expensive, and depending on the size of the computation, people would come up with ways to make those algorithms faster. So there is an indication you would get for how long it took by looking at this. So that's what the last line there shows you. Okay, now we know what this looks like, what the parameters, their significance was by writing summary. Let's now try to do some predictions. Okay, so we have the variable, the fit we did, glm.fits is the variable name, and we are going to use it to predict, much like what we did in the linear model case. When we did linear regression, we will use the function called predict, and we can apply this on a fit that on a model that we have fitted. And this particular one is called glm.fits. That was the variable used, and we're going to predict on things around response. Okay, so that's what line 14 is showing us. We can do that, and we want to see logistic regression could give us probability, will give us probabilities. So we have these parameters that we have obtained from the model, and in this case, we are interested now in finding out the response. But what we get as a value is probabilities. And I have told you last time when we introduced the topic of classification, in most cases, that's what you are more interested in rather than the ultimate classification. First of all, you could do whatever you want with those probabilities. You could have a little bit of decision to make on when to put a cutoff, right? So how high should be a probability for me to take action? If it was, for example, the fraudulent and not fraudulent type of claims in insurance, the example I used, and you have a probability that your model is saying it is fraudulent with chance of 0.7 and the amount of dollars used was $10, I'm sure you would not bother to find out. But if it was like 100,000 and the probability was 0.7, or then you would carry, some weight to it. And so when do you want to say something is below and above would depend on the probability. And sometimes because you also have subsequent things that need to be done. So the probabilities that your machine learning model is associating with this prediction is more important than the classification itself, or it is a basis for the classification. So let's find out what probabilities it gave us on these predictions, and we're going to look at the first 5. So that's what line 15 is doing, and so let me do that. And here I get, so there were 5 of them that I'm getting their probabilities. And you can see this thing is consistent, unfortunately, with what we suspected, that these predictors are not helping us very much because they were not significant. And here we go. So the response we are getting is much like around 50% anyway for this response, for the whether it is going up and down. And so we have 0.5 in the first case, 0.48 in the second case, but they are in the same neighborhood. Now, we can turn these probabilities into saying whether the market has gone up or down. And now, because this is probability we have calculated, it will be very fair to say I will call it go up if it is the probability is greater than 0.5, and I will call it go down if the probability is less than 0.5. That's a fair thing to say. And so that is what line 16 is doing. But it is also doing or showing you this particular one thing that you probably haven't seen or done in R before. You can write this in a single line of code by using a command called if else. And this is a shorthand for saying you will do the first thing when it is true, you will do the second thing when it is false, is what it means. And so what is the first thing and what is the second thing? Well, the condition is the probability in this case is greater than 0.5. So I get a Boolean value now. It would either be true or false. And when it is true, I will call it up. When it is false, I will call it down. That's what line 16 is doing. Okay, so we have now found out a way to do this. And we're going to do a little bit of looking into the result we got with these predictions. And we want to have access to this stock market data frame, the variables in it, without having to explicitly call them with S market and then $ and so on. We want to get them available in our console. So a command to do that, you have seen this many times or several times before, is to say attach. And so that's variables are available. And so I'm going to now do a table, and table is a function name in R that would help you get whatever it is that you have on the predicted ones and the actual ones. And so we are going to use the GLM predict and direction predictor, that one of those features is the one that we will use for having to think about the table itself. So let's see what it would give us. And the table looks like this. And so I have the direction up and down, the actual values, and I have got the predicted values on the rows and the columns. And so when we get things right, numbers will be on the diagonal. When we get things wrong, they will be off diagonal. And we did get a bunch of them wrong, you can see. So if you add up all these numbers, there is what you have on the off diagonals one is pretty significant. Let's see what our prediction is saying in terms of how many times it got it correct. If we were to do this manually, we would do whatever is shown in line 19. We add up the diagonals and divide it by the total. And if we want to see whether that one agrees with what our prediction has done, we'll compare it with what's written in line 20. So first, let me do line 19. the manual calculation, 0.52. This is where about half the time we got it right, is what it means. And if I write mean of when GLM predict is direction, when they are equal, that is, I'm now automatically saying whether I am on the diagonal or not. And so what is predicted and what is in the actual value in the response variable, in the predicting, in the feature or the variable called direction, when they agree, that's the double sign equal, I will get a 1. And so if I take the mean of this, then I would get the rates, right? And I want this number to be equal to 0.5216 if everything is going fine. Let's see if that's true, and it is. And so now we have seen at least how to do logistic regression and how to look into it and how to evaluate its performance and do prediction and evaluate its performance. One thing that we will be devoting time on Wednesday is to do cross-validation. Whenever we have a method that we want to see how well it is doing, there is a very good technique called cross-validation, especially when it is done right. And there are times when people do it wrong. What you do mostly when you do that is to classify your data into training set and test set. Even if you are not doing that for cross-validation, you would do that. And so you can train your model on a certain part of the data set and use the remaining portion of it for testing. In this case, we're going to do this now on the data set that we have, and the training will be used for the data set that has got year prior to 2005. And everything then afterwards, I don't remember when this data set ends, will be the test set. You would be careful about how you split your data into training set and test set usually. And in this case, this is probably a reasonable thing to say. We are training it on a past history, right, up to 2005, and we are going to use it for things that would come later on. We are ready now to not to be kind of expect magic out of this thing, because the variables are not very helping us very much, and because it is how stock markets are. They are they behave in a very sporadic way, or whatever it is. It's not, they are not that predictable is the point. So I'm going to give you a heads up for what we should expect, but this is how we would divide it. The syntax is what I am more interested in now. And so the training set now will have all year that is less than 2005. And so we have stored that in a variable called train. And so we're going to give a variable name for that subset of data. And I'm going to use this thing called smarket.2005, just a good indicator for what I'm doing. And we will go to the smarket, that's the data frame, and we're going to pick everything that is not train. And this will be our test. So we have the training for year 2000, less than 2005. So we have values for it, and so everything that is not in it is what this exclamation mark .train means, and then we are going to pick all the rest of it. Okay, so let's find out what this variable or this subset of the data that we just found out looks like, and looks at its dimension. So we got the 9 variables which were there, but otherwise there were 252 cases. We have a total of 1,250 in this case, but those were the ones that satisfied this condition were 250 of them. Okay, so now we are going to look at, we're going to be predicting, and so that we'll have a variable called direction 2005 to show the places where it was not right. This is a test where the direction is for those cases where they are not in the training. In other words, they are in the test. Okay, so we have stored that variable, and we're going to now fit a model on the thing that is the training set. So unlike the previous case where everything was used, now we are going to fit a model on just the training set. Everything else is the same. So we've got the family binomial, we have all the variables included, we have the response variables direction, but now we have used a subset, just part of it, and that is the one that we call train. And let's predict now on the test. That's what this line 28 would do. And so we're going predicting, we are using that same model we just fit, but now we're using it on the variable that we just saved a couple lines ago, which is not the training, which is the test, and the test set, the other subset, and we're going to still be looking at the type response. Okay, let's do that. And let's see now what we get on this test set with our model and with just use the same if-else command before, and whenever the probability is greater than 0.5, we will call it up. When it is less than 0.5, we'll call it down. Okay, we did that, and now let's do our model. First, we will do it on the test, and we get this value, and it's less. It was 202, I think it was, and this is the values we got. We still are making a lot of mistakes. Most of or many things are off diagonal, and so we see the value if we compute it, and we will compute the mean of this to show us, and it did get worse a little bit. So we used a training set, and we are testing it on what was left, and so we did slightly poorer than what we did before, but it still is not very much, if you ask me, not very much of flipping a coin, half. In fact, we're doing slightly worse than flipping a coin to determine whether the stock market was going to go up or down. The other one shows you the performance of this on the one on the training set and the other on the test set. So the test set was the first one, and the one that is doing on the next one, or the other way around. The two numbers should add up to one. I misspoke. So the two numbers should add up to one. One is when they were equal. That's the thing that you got right, and the thing that is not equal is what we have in the other one. So we could talk about this one either in terms of how many things we got right, or in terms of how many things we got wrong. Now that we have seen this model, and using all of the variables didn't help very much, we could be tempted to see if there is anything better we could get if we use a smaller model. By smaller model here, I mean use fewer of the predictors than the real. There are 9 of them. And let's say if we choose just the first and the second lag. So we're not going very far back, is what it means. And that's what our new model would do in line 34. And the variables used, the predictors used are only lag 1 and lag 2. And so we have a new name for it, and we're going to predict using the same training set and test set like what we have done before. And we are going to go up and down depending on whether the probability is greater than 0.5 or not. And let's see if we do any better. And we'll do our confusion metric. This is, by the way, called confusion metrics. And it looks like we did better this time around. And so again, intuitively, it would make sense. We just made our predictions less valuable because we're looking at data that is not helping us very much. It actually helps to just look at the previous two rather than everything else, because they were taking us the wrong direction, is the kind of clue we'd get from here. All right, I'm not sure what I wanted to accomplish with line 39, but I'm going to skip that and take you to linear discriminate analysis. Okay, let me move the cursor a little bit up so you can follow me along better. Anybody else got any questions for me so far? And I'm not sure if I have the chat session open. I have it here. Okay, so the yes from Smith should have been to something else. All right, so I'm assuming that you're all with me. Let me see how we are doing on time. So we've got a few minutes, and I think it is enough for us to cover. Okay, what we will do next is do linear discriminant analysis, and we are going to go back to another data set, and this time we're going to go to the one that we have seen last time, the Massachusetts data set, and so we are going to include it. We did here, and the function name we need to call to fit a model in using linear discriminant analysis is called LDA. And we do, otherwise the call of the function is very similar to GLM. And you have the response, and then you've got the predictors that you would use, and then you would give it the name of the data, and if there is a training set that you have used. So everything that I am going to be doing now is on exactly the same data set, using the same training set and test set. And in fact, it would be interesting to see what linear discriminant analysis would tell us or would give us compared to what logistic regression would do. Those of you who were last time, you would remember the distinction between the two, and when linear discriminant analysis is better to use than logistic regression. And in this particular case, we will see if it helps us to do anything newer, but there are times when it is a better option, especially when things are clearly separated, is what classes are clearly separated is what we saw last time. Okay, here's our fit. We call that function with this name. And so we have a model, and we will probe it by, we can just write the name of a variable, usually would give us a little bit of a summary that is not too detailed like what you would get when you write a summary, but here we have it. So there is the name of the function, the call, and what is up and down. It's very much similar to what the linear regression did. And then you can see the confusion metrics also computed when we write LDA fit. And we have now a few lines that are about prediction. So we can do prediction much like what we did with logistic regression, and we call the function predict. We give it the model, and we give it the test, in this case, the test set we have created, the variable name we have created. And let's see what we found so this line in line 46 that I just ran, names, is just like you apply names to a data frame and you would get the details of it. Here is one of the things that you can probe about linear discriminant analysis and things called posterior and X and class. That's what you got. This is a name, this is a model fitted, and so you can get names of this kind. And the reason I wrote this one is because we're going to use this one to create to have our confusion metrics, and we should know, if we know them by name already, great. If not, then we can find out about them and then use them. So what I'm going to do in the remaining few lines will make use of the variable names that are associated with this model. In other words, with what linear discriminant analysis is implemented as inside, okay? And so we are going to access the thing that is called class, and we'll give it a variable name. We'll call it LDA class. That's what we have done in line 47. And here comes our table. Now we are going to look at LDA class, whether that direction, and then compare it with direction, our confusion metrics, and here we get it. And so much like what we did before, where off diagonal things are wrong and diagonal things are right, and when we have the downs and the ups in the way that you see displayed here. If we now do the mean for this, which is another way of saying how many times did we get right, we did get better results than we did with logistic regression. If you now remind yourself for a second that you are working with a stock market data set, and this was the kind of improvements we were seeing, whether we were using the entire logs or just two of them, was in the neighborhood of 0.5. In some cases, it was 0.48. In the other case, it was 0.51 or 0.52. This is fairly significant. I mean, you have improved. And if you were to use this to bet money or to buy stock or not, you would rather have this than the logistic regression one. So it's not a huge margin, but that's not the method's fault. The method is fine, or both of them are doing fine. It was the data set that was troubled or difficult to predict generally, but between the two, especially when it could be as bad as being under 0.5, then linear discriminant analysis is doing a better job. That is probably more than learning the syntax and how LDA is used. This is also a lesson that you could draw from this one. The next few lines that I'm showing you will just count how many, and it's for me to show you an example of how to access the class, variable, and X, names associated with the LDA function, and that's what these things are trying to recall. When things are greater than 0.5 and when things are less than 0.5 is what I'm trying, and they are being added. And so if you add them up, they would sum up to how many cases you have in your data set. And the last thing I want to show you is a call to one of the features that this thing has called posterior. And you may remember the discussion we had around this, the theoretical discussion, but you can get the values here in this way. All right, that was what I wanted to show in terms of walking through code. The code is not commented, so you probably would have to watch this one if you haven't followed me along. But if you have followed along now, you don't need to watch this again. I think you will be just fine looking at the code yourself another time. And I'm going to stop sharing now and see if there is anybody who's got any question for me. Oh, I should now get back to Chris, and we have 1 minute. So I need to go to the place where I wanted to show you where to sign up for these meetings. And so stay with me, all 54 of you. Stay with me for a minute. And Chris, please take over and go to we remember we had this Excel sheet, not in Blackboard, but the Excel sheet we used for signing up when people were trying to get teammates, right? I can put it in the chat, but I think you will find it yourself. Go to that Google Doc, because I'm using that same one to show where we're not on Blackboard. I'll type this up later on when I do the post-class announcement.
Where I'm supposed to go.
You are supposed to go to the place where people signed up for their teammates, and I'm going to get you there. I'm going to put it in the chat session for a second. Give me a second. Get out of Blackboard. Okay, I have it now on the chat session. I've lost one person who has to go, but the rest of you are here. So you are going to stay with me for another 30 seconds. Okay, whoever is able to get to what okay, Chris is, oh, perfect. Okay, so here's the times, and we're going to use this same place. And I found a couple reasons why I prefer to do it this way. So the options I have are here on line 25 to 30. Tomorrow, 5 to 6. Wednesday, office hours split into 2, 10:30 to 11:30 or 11:30 to 12:30. Option 4 is Wednesday again, but 4 to 5. Wednesday again, 5 to 6. These are options 4 and 5. And then option 6 is Thursday, 9 to 10 a.m. So what you do is just go ahead, write your name, write the class level, and then you tell me all the choices that you are available. I'll take this, yes. Perfect. So Tyler is doing, Magnus is doing a great job. So you get the idea. So go there, fill out your things. I hope most of the things would work out for teams, because I don't want to meet individually. I want to meet as a team. So if there is a team of 2, I would like all team to have the same thing. But if you write this way, then I should figure out what to do. And I have a reason. I didn't want to do a doodle poll. You can come back and change your mind. I'm going to monitor this, and I'll tell you on Wednesday what I have. Or before then, in fact, because there is a Tuesday one. Okay, so go ahead and complete this one, and I think we're good. And now you can go. All right. Thanks again, Chris, very much for all your help with screen sharing today. So you all know this, and go complete it. And I will see you all on Wednesday. Okay.